Hi there everyone. In this video, I just want to take a quick second to explain some of the notation and terminology that we're going to be using for the rest of the semester because it's super important. So here's what I want you to imagine. Here's the Earth. The Earth has a ton of people on it, and every single one of them has been alive for a certain number of years. If I could ask every single person in the world how old they are, I could compute the average of the whole population of the Earth. But I can't. We don't know the average age of every single person on the Earth, right? We can't get that information. It's just too many people. What do we do instead if we want to compute the average age of the people on Earth is we select a sample and see how old all those people are. And then I can use the average of that sample as an estimate for the actual average of all the people on the planet, which of course I can't know. It's just too many people. So I could do that by measuring the average age of the people, say, in our class. Then I might get kind of skew results because you guys are all pretty close to the same age and are fitting a demographic that is not a cross-sectional representative of the whole world, right? Just because the average age of a bunch of college students is 20.1 years old, that does not mean that the average age of the entire population of the planet is 20.1 years old. Right? So my sample that I picked, not a good choice. And what we'll find out in this chapter is that there is really only one way to pick a good sample, and that is to do so randomly. So we're going to learn about really one technique for choosing a random sample, and a simple random sample is the best and only way to select a sample from a population. Now, just while we're here, I want to show you some stuff about notation. If this were possible, if we could compute the average age of the people of the entire population of the planet, we would call that mu. Right? So that's the symbol that's always used for the population mean, right? The average of the entire population of the planet. Usually that's a number that we don't know. Like I don't know the average age of the collection of all the people, the billions of people that live on the planet. But we'll use that Greek letter mu as a stand-in for that population mean when we need to talk about it. Another letter that shows up having to do with the population is sigma, and that's the standard deviation, also a Greek letter. And these are both lowercase Greek letters, so mu and sigma lowercase. And this one I already said is the population mean. And this one is the population standard deviation. And this is, again, something we don't really know, something we can't really know. The whole point of statistics is to estimate those values. I can't even, collect that data, all the ages of all the people on Earth. If I don't have the data, I can't compute the mean or the standard deviation. Now, when we select a sample, we can compute a mean and we can compute a standard deviation. And those things have special notations too. So our sample mean, we always write as x bar. And a sample standard deviation also has special notation that is consistently used across statistics, and that's just the lowercase letter s. So that's the whole story. Right? There's a whole population that is too big for us to know. That population does have a real average of whatever thing we're measuring, and we call it mu, even though we probably can't know what it is. And there's a standard deviation for that population, even though we can't know what it is. So we call it sigma when we need to talk about it. When we're talking about samples, we use x bar and s for the sample mean and sample standard deviation, which are things that we can compute. Okay, hopefully this clears up some things.